In this video, we're going to look at how we can do some calculations for chemical reactions. So to do these calculations, we're going to develop what I've called here a roadmap. And this is just a tool that you can use to help you remember what conversion factors to use to convert between grams and moles or moles and moles when we're looking at chemical reactions and equations. So I'm going to start my roadmap with grams of substance A, and we can convert grams into moles by using the molar mass, and that's found on the periodic table. Now, in a chemical reaction, you might need to convert between one substance and another substance, and you do that through the moles. And so to go from one substance to the other, you have to find your moles first. And so to convert between moles of one thing and moles of another, you use your mole to mole ratio, which means that you need a balanced chemical equation in order to get your mole to mole ratio, to use that as your conversion factor to go between moles of one thing and moles of another. And then if you need to find grams of that other substance, we'll just say grams of B. Again, you use molar mass to convert between moles and grams. So here's our roadmap. You can think of the things that are in the boxes as cities. So you can travel between the cities, you just have to stay on the roads. And the arrows are the roads. They tell you the conversion factors that will convert between those two things. You can start at any of the locations and you can end at any of the locations. So you could start at grams of A and convert to convert to moles of B. You would just have to go through moles of A first. So you have to stay on the road, stay on the arrows. Let's look at a couple examples of how we would use this to solve problems. I've just shrunk that roadmap down and it's up in the top corner there. Let's look at this problem here. How many moles of nitrogen are produced when 16.5 grams of oxygen reacts? And I've given you a balanced equation there. When I do these problems, I like to write down underneath my balanced equation what I know and what I'm looking for. It just helps me to stay organized. So underneath oxygen right here, I'm going to write down 16.5 grams because that's what I have. That's what I'm starting with. And then from the question, it says how many moles of nitrogen are produced. So I'm going to put a question mark under nitrogen with the unit of moles. So that's what I'm looking for. So I've kind of drawn out everything I have from that problem and I've just written it down. It helps me to keep track of it. Okay, so for this problem, we are starting with grams of one substance. So we're going to start grams of A. We're going to end up with moles of a different substance. So we're going to end up with moles down here. So we have to travel along our roadmap. So that means that we're going to start with grams of oxygen. We're going to use the molar mass as our first conversion factor to convert to moles of oxygen. And then we are going to use the mole to mole ratio from our balanced equation to convert from moles of oxygen to moles of nitrogen. That's our plan. So let's start by writing down the amount we're given, which is 16.5 grams. Important to write down what it is so we don't get confused. Grams of oxygen. First conversion factor is the molar mass. That's in parentheses between our grams of A and moles of A from our roadmap. And so we go to the periodic table and we look at what the molar mass of oxygen is. Each oxygen atom has a mass of 16.0 grams per mole. And we have two of them because it's O2, so 2 times 16 gives us 32.0 grams of O2. That goes on the bottom, so we have our units cancel. And that is how many grams are in 1 mole of oxygen. Okay, so now we have successfully converted from grams to moles. Our next conversion factor from our roadmap, the parentheses next to the arrow between moles of A and moles of B, is multimole ratio. So we get that from the coefficients in our balanced equation. So we look up at our balanced equation and there's a 3 in front of the oxygen. So that means that for every 3 moles of oxygen, 2 moles of nitrogen are produced. That's our multimole ratio. Moles of oxygen cancel. We're left with moles of nitrogen as our unit. That is what we are looking for. And so now we can plug that into our calculator. 16.5 times 2 divided by the product of 32 and 3. So rounding to 3 significant figures, our answer is 0.344 moles of nitrogen. Okay, let's look at one more example. Here's our next problem. How many grams of oxygen are needed to react with 35 grams of ammonia? In this, so I'll start by writing down, like what I did before, writing down what I am given in the problem and what I am looking for, and I'll do that underneath my balanced equation. So I have been told that we have 35 grams of ammonia, NH3, and we are looking for how many grams of oxygen can react with that. Okay, so we are going from grams of one thing to grams of something else. So we're going to start at grams of A, travel along here, this path, and we'll end up here. And so that means that we are going to have 3 conversion factors that we will use for this. So our first thing to do then is to write down the amount that we are given, which is 35 grams of ammonia. We are going from grams of A to moles of A, and so we're using molar mass as our first conversion factor. We go to our periodic table and look up the molar mass of nitrogen and hydrogen, remembering that we have to multiply the mass of hydrogen times 3. So nitrogen has a mass of 14.0, hydrogen has a mass of 1.0. So 3 hydrogens, 1 nitrogen gives us a molar mass of 17.0 grams of NH3, and that is in 1 mole of NH3. Okay, so our grams cancel. We are now in moles of ammonia, so moles of A, if you will. We're going to continue on our roadmap. The next arrow says multimole ratio to convert to moles of our other substance. So we come up to our balanced equation and we have a coefficient of 4 for ammonia. So we put that on the bottom. 4 moles of ammonia reacts with 3 moles of oxygen. Okay, that cancels out moles of ammonia. So final conversion factor is our molar mass to get us to grams of oxygen. So in this time, we're going to put 1 mole of O2 on the bottom so that our moles cancel. Oxygen has a molar mass of 16. There are 2 of them. So it's 32.0 grams of O2 on the top. Moles cancel. So now we can plug it into our calculator. 35 times 3 times 32, and then we're dividing that by 17 times 4, and rounding to 3 significant figures, we should get 49.4 grams of oxygen. Okay, so those are a couple of examples on how to use this roadmap to help you keep track of what conversion factors you need to do next when you are converting between grams and moles in a chemical reaction.